Lesson 10.7, Counting Principles. The fundamental counting principle is that if events E1 and E2 occur in M1 and M2 ways, the number of ways the events can occur is M1 times M2. So in other words, if there's multiple events, the total number of ways they can occur is just by multiplying the ways each of them can occur. For example, a lock will open with the right choice of 3 numbers. How many different sets of 3 numbers can you choose if each number is from 1 to 30, inclusive, so it includes 1 and 30? Part A, with repetition. Well, we have 3 numbers. So my first number, I can choose any of 30 numbers. The second number, I could choose any of 30 numbers. And the third number, I could choose any of 30 numbers. Multiply those together, and we get 27,000 different numbers. Part B, without repetition, is similar, but I have 30 choices for the first number, but if I can't repeat, then there's only 29 choices for the next number, and 28 choices for the next number. So it's a few less choices. How many license plates can be made if each is 2 letters followed by 4 digits? Part A, with repetition. All right, so we have 2 letters and 4 digits. So with repetition, there are 26 letters. So my first letter could be anything of 26, second letter could be anything of 26. But there's only 10 digits, 0 through 9, there are 10 digits, so we'd multiply all those together, get 6760000. Part B, without repetition though, my 2 letters and 4 digits. First letter is 26 choices, but after I choose one, the next letter has only 25 choices. The first digit has 10 choices, but the next digit only has 9 and 8 and 7, because I can't use any of the same ones again. Multiply those together, and you can see we have quite a fewer choices. All right, so this leads us to the idea of a permutation. A permutation is the number of ways to order n objects taken r at a time. So the fundamental counting principle that we just had could have many copies of the same object. Permutations is only one copy of each object. And it's calculated in PR is n factorial over n minus 1 factorial. But there's a button on your calculator. It's also, it's by where the NCR was. It's in the math menu. Go over to the probability, and then down to NPR, and you enter N, NPR, then the R. So how many ways can 8 children line up in a row? Now for children lining up in a row, the order is important, because it's important who's first and who's last. Woohoo! All right, so n is the number of objects. So n is the total objects. R is the objects that you're actually choosing, or that are chosen. So in this case, n is 8 that we get to choose from, and we are actually choosing all 8. So it'll be 8p8, which we'll just put in our calculator. I'd put it in as 8npr8, and you get 40,320. There's quite a few ways just to line up 8 kids. How about this one? A club has 24 members. How many ways can 5 officers be selected? Well, order is important here because it matters who's president and who's vice president and so on. So n is 24, but we're actually only choosing 5 of those. So it'd be 24 P 5, which we could hit the button in our calculator and get 5,100,480 different choices. But let's look at this using the formula. It was NPR is n factorial over n minus r factorial. So for this one, it would be 24 factorial over 24 minus 5 factorial. So 24 factorial would be 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times and so on. The bottom, 24 minus 5 is 19, so it's 19 factorial. So it'd be 19 times 18 times 17 times blah, blah, blah. Notice all that cancels out. And it's just 24 times 23 times 22 times 21 times 20. Which, if we use the fundamental counting principle, how many choices for the first officer? 24. After that one has an office, how many are left for the next one? 23. After those 2 offices have been chosen, 22 people left for the next, and then 21 and 20. Notice they are the same thing. How about if we have several copies of some of the objects? So some of the objects are exactly the same. We still only have one of each object, just that some of the objects are exactly the same, such as A, B, and B. Well, BAB and BAB are the same, even though, you know what, I switched the B's. So we'll only count that as one arrangement. So we're looking for the orders that actually look different while choosing all the objects. And for this one, we're choosing all the objects. And it's n factorial over q1 factorial, q2 factorial, q3 factorial, where n is the number of objects, and the q's are how many times each object is repeated. For example, how many distinguishable ways can we order the letters in the word banana? Well, let's see. If it's n factorial, the key word is distinguishable, and notice that some are the same, so we'd have to use this formula. N is the number of total objects, that would be the 6 letters in banana. And then the q's are how many times each thing's repeated. We can see the n is repeated twice. And we can see the A is repeated 3 times. And you don't have to put the 1 for the B because 1 factorial is just 1. And you put that in your calculator, and you end up with 60. So you could actually write out all the 60 options. I'm not going to for you, though. What if we just wanted groups but no order? That would be combinations. In this case, ABC would be the same as BAC because it's the same group of letters, and we don't care about the order. And we've actually already had the combination before when we did the binomial theorem. The NCRs are the combinations. For example, there are 31 students. How many different groups of 4 can be made? Well, n is 31 because that's how many we're choosing from. And our r is 4 because that's how many we're actually choosing. So n is how many we are choosing from, or the total number of objects. R is how many we are actually choosing. So this would be, now we want different groups. The order that the people are chosen for the group doesn't matter. We just want the groups. So this is a combination Order does not matter. Put it in your calculator. Get 31,465 different groups out of the 31 students. All right, our last example. Let's say you're forming a 10-person committee from 9 women and 12 men. How many different committees if there are 5 women and 5 men? All right, first of all, there's no order. It's just a committee, it's a group. So that means we're going to use a combination. But we actually have 2 choices. We have to choose the women and we have to choose the men. If we have 9 women to choose from, we're choosing 5. We have 12 men to choose from, we're choosing 5. And according to our fundamental counting principle, if we have these choices, you multiply the choices together, and you'll end up with 99,792 different committees. That's all for today. Have a good day.